What is up, math superstars? In this edition of Mr. Peterson Presents, I'm bringing to you lesson 1.1 on ratios. So at the end of this lesson, you will be able to describe and compare data using ratios, and you'll be able to use the appropriate notations. So the question is, what is a ratio? For your notes, a ratio is a comparison of two quantities by division. So let's give you an example here. So example 1 on your notes says, write the ratio that compares the number of footballs. So we're going to underline key things. So we're looking for the number of footballs. And in all ratios, there'll be word to or out of. And then we're going to underline the second part, which is the number of tennis balls. So this is important information for us to know. So before we even figure out how to write ratios, let's figure out how many footballs there are. So the number of footballs, there are, we just count on 1, 2, 3, 4 footballs. And the number of tennis balls, so we go and count those, 1, 2, 3, 4, 5 tennis balls. And so in our question it says write the ratio. So another key part here. So we're going to write the ratio. And so here's how we're going to do this. So we're going to write the ratio 3 different ways. The first thing is we can write this as a fraction in simplest form. So number 1, so our fraction, we're just going to write this in order that it shows up in our example here. So the number of footballs is 4. And the number of tennis balls is 5. So we use our fraction bar. So the first one is footballs is 4. The second one, tennis balls, is 5. So that's a fraction in simplest form. Another way we can write it is using the colon. You use this, obviously, to make your emoji smileys if you still do the colon and then the parenthesis. So using a colon, we can write this 4 colon 5, using the order that it comes in. And then the third way, we can just use the word to. So we can also write this as 4 to 5. So we can write ratios 3 ways: as a fraction, using the colon, and using the word to. So here's our second example. So go ahead, let's pause our video, give this a try, and the video will start, and it's asking you this question: write the ratio that compares the girls to the total number of students, and we're going to write the ratio 3 ways. So first of all, we need to figure out some useful information here. So it says write the ratio that compares the girls. We're going to circle the word to, because that's going to tell us the colon, the fraction bar, the word to. And then we're looking for the total number of students. So first step is we're going to count the number of girls here. So write down girls, and we need to come up with a total. So the number of girls here, so we have 1, 2, we have 3 girls. And let's figure out how many total students we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 total students. So the first step is we're going to write the fraction in simplest form here. So for number 1, our fraction, so we have girls is the numerator, the total number of students is the denominator, 9. But we know this is not in simplest form. We know that we can divide the top and the bottom by 3, our greatest common factor. When we do that, it simplifies to 1 over 3. So we can say for every 1 girl, there are 3 students. So our next step here is we're going to use the colon here. And so we're going to use the fraction in simplest form for the colon. So for number 2, we can write this as 1 colon 3. And then we're going to use the word to. So we can write this as 1, 2, 3. So another thing with ratios, we can talk about equivalent ratios. So these are two ratios that have the same value. And so we're given a couple examples here. So we have 3/4, or 3/4, and we have the ratio 12/16. So the way this works is we're going to simplify both fractions. And so 3/4 is already simplified. 12/16, our greatest common factor here is 4. So when we divide 12 divided by 4, that equals 3. 16 divided by 4 is 4. So we know that, yes, these are equivalent ratios because 3/4 is equal to 3/4. So the key for equivalence is simplify. But in our second example here, we have 12/17 and 10/15. And so key here, let's try to simplify. So 12/17 is already simplified. Let's go ahead and simplify 10/15. So we're going to divide the top and the bottom by 5. So when we do that, it simplifies to 2/3. And so right now, we're kind of stuck because we say, okay, how big is 12/17? Well, the way we can do this is we're going to rewrite this in 2/3. We could cross multiply to figure out if these are equal. So what we do is we take 17 times 2 equals 34, and 3 times 12 equals 36. And so when we cross multiply here, if these two numbers are the same, 36 and 34, they would be equivalent. But since they're not, we can say that these are not equivalent or equal. We'll do a little sad face.